I used the dishwasher pump motor for the blower on this dust collector. So when some friends were getting rid of an old dishwasher, I said, sure, I'll take it. I could use the motor in that. Unfortunately, this one doesn't have a nice big induction motor on it like the other one does. But let's see if I can make use of that. So this motor has got a bunch of electronics on it, but it says here 120 volts AC, 0.9 amperes, 55 watts. So I should be able to just put a plug on that and put in an electrical socket. Let's open this up first. I think this just, twists out like this. Yeah. And there's the impeller. And the way this snaps to certain polarities tells me that's a brushless DC motor, or a synchronous motor, but all the electronics here basically synthesize the AC of the right frequency to make this thing run. Let's see if it still works. Got it connected to a spare power cord. It runs. Okay, this says 6,000 RPM. Playing around with this motor, it turns out it runs at about 6,000–7,000 RPM, but if it's got no load, sometimes it'll fall back to about 3,500 RPM. And I think that's because in the dishwasher, if there's no water for it to pump, there's no reason for it to run that fast. Let's see if I can get that impeller off. Well, certainly not without breaking it. Oh. Oh, I guess that would have just screwed right off. Whoops. Oops. Oh. Looks like I need to keep that plastic part because that goes in here. Yeah, the bearings are in here. Whoops. I'm going to try spinning a paddle in mid-air just to give it some load. $44 watts. Now this reads 7,200 RPM, but that reading is actually double because it's double counting each RPM with 2 blades. Let's see if it runs faster if I shorten the blades. Still 7,200 RPM, but only 35 watts. From experiments, this is the biggest impeller I can spin up with this thing, which is not very large, but I'll try making a blower out of this anyways. I pressed that brass nut that came with the motor into this piece of Baltic birch plywood, and that will be the hub. I just have to glue it centered on here, and with this extra glue I can't really see it. Wipe that out. So while I'm waiting for the glue to dry, I thought I'd talk a little bit more about the design of this motor. This is the rotor of this motor, and it's clearly a permanent magnet with north-south oriented side to side. By putting the rotor inside of this armature, that essentially makes it a synchronous motor. And if you want to be able to run that at anything other than line speed, you have to essentially drive it with a variable frequency drive, which is what I thought this would be, except for this to actually be a variable frequency drive, it would have to have some storage elements on it, as in some good-sized capacitors, which is to say this is not a variable frequency drive. All this is a circuit to start a synchronous motor. Because if you just power up a synchronous motor with AC, unless it already is in phase, it never gets in phase and it just sits there humming. Which is to say, this motor probably is only meant to run at 3600 RPM or 60 turns per second. And any readings that I got that were different from that were either because it was doubling because this thing was reading twice because of the paddle I had on there, or just an error in the reading. Now this thing typically read a little bit faster than 7200, but that's because this thing is a little bit inaccurate. So why would they do this? And I think I know the answer. So the clever part here is there's actually no water seal between the pump part, because the O-ring goes here, and this, which is to say water can actually get in here, and these bearings are actually lubricated by water. You can even see there's some holes in there for water to get in there. So basically the water can get all the way down in here and it's all sealed. So this rotor is actually part of the thing that is the inside of the pump, which of course means you don't need any sort of seal for the spinning shaft because those always go bad eventually. Now you could have done this with an induction motor as well, just a split phase motor, shaded pole motor kind of thing. Why would they use a synchronous motor? I think the reason they did that is because of this plastic housing around the rotor, there's actually quite a bit of gap between the rotor and this part here, and that requires a lot more magnetic field to overcome, which means normally you'd need more power on the coils here. So on a regular induction motor, this gap would be very small. But on here, because we actually have the magnetic field coming from this, which is a permanent magnet, the strength of this permanent magnet doesn't use up any energy continuously. So basically, the magnet strength from the permanent magnet rotor helps overcome the gap, which means you don't need extra energy in the coils. And so therefore you get your efficiency back. But because this is a permanent magnet, that makes it a synchronous motor. And that means you need some variable frequency or some approximation thereof to start it. And that's what all this electronics is for. Hey look, it's a circle jig. Well, it wanders a bit, but at least it spins. I should balance this rotor somehow, and I figure the best way is by putting a machine screw in here. And that's got a countersink on it. And let's see. This side seems to hang lowest. Consistently here, so I need to cut off a little bit here. I'd say that's an improvement. I didn't film making the rest of the blower housing and figuring out how to make the motor mount, partially because I had a toddler roaming around the shop, and partially because I've filmed this process many times before making other videos about building blowers. So if you want to see more on that, watch one of my other videos about making blowers. See links at the end of the video. Uh-oh. Let's try that again. It's running at 60 watts, so it's probably a little bit overloaded. No, it's at 50 watts. It's not perfectly balanced, but I've been experimenting with putting little weights on various fins, and just by moving them around and seeing where it runs the smoothest, I've kind of figured a weight here and here puts it closer in balance. I'm drawing just 35 watts of power, maybe 36, and the RPM is 3600 RPM, so that's working really good, but it's actually a failure because the rotor on here is too heavy for this motor, and on starting up it just gets confused, and unless I block the airflow it never actually makes it up to speed. So it's just sitting at 3100 RPM, and eventually it'll give up. And now it's given up. But if I block the airflow when it starts, now you can see it's trying to get up to speed, but it's having difficulty. I think it's up to full speed now. Yes. I guess I just have a fascination for oddball motors, but for the most part, I don't think this type of motor is worth the trouble. But having said that, I just swapped out this blower on this dust collector for the one I just made, because this one sucks a lot harder. It really collapses this hose. The bearings on this motor are actually meant to be submerged in water for lubrication, and I just oiled them instead. So I don't know how long that will last, but I'll just use it until it breaks, and if it breaks I'll just put this old blower back on.